Hello, everyone. May your morning be colorful, joyful, and blessed. This is Mrs. Rose and V. Parane from Payapa National High School, and this video is for our grade 7 learners, grade 7 science, quarter 1, week 3, 4, and 5. Yes, 3 weeks po ang discussion for this video. So, kaya ito ay tinawag na video compilation. So, the video compilation is also made by our from DepEd family. So, merong mga teachers na nagdi-discuss din about the grade 7 science at gagamitin po natin para mas madali po nating maintindihan. Actually, yung week 3 at week 4 po natin is translated in Tagalog para mas madali nating maunawaan. But our week 5 concentration of solution is still in English, pero mas madali naman po ang explanation ng concentration of solution. So guys, are you ready? Okay, so let us proceed with our quarter 1, week 3. So, this is substances and mixtures. When different substances are physically mixed together, mixtures are formed. But how does a mixture differ from a pure substance? Have you ever prepared a chocolate drink? Have you ever noticed what happened if you let your chocolate drink sit for a while? Well, sometimes the chocolate powder will settle on the bottom of the glass. We call it mixtures. Sometimes two or more ingredients looks the same when mixed together, and sometimes they do not. In this lesson, you will find out the difference between mixtures and pure substance based on a set of properties.
Naitanong nyo na ba bakit maalat ang dagat? Ito ay dahil ang tubig neto ay may malaking porsyento ng asin. Kaya itatanong ko sa inyo, ano sa palagay nyo ang tubig dagat? Isang substance o isang mixture? Babalikan natin ang tanong na ito mamaya. Ang matter ay pwedeng hatiin sa dalawang kategory: pure substances at mixtures. Ang pure substances ay nahahati ulit sa dalawa, elements o kaya ay compounds. Ang mixture naman ay nahahati rin sa dalawang main types, heterogeneous or homogeneous. Patatandaan na ang homogeneous mixture o tinatawag nating solutions ay na-discuss natin nung nakaraang episode. Kaya kung gusto nyo ito mapanood, siguraduhin na click mo ang link na ito. Pag-usapan natin ngayon ng mas malalim ang substances at mixtures. Ang mga substances ay binubuo lang ng isang klase ng atom o kaya ay ng grupo ng mga chemically bonded na atoms na tinatawag nating compounds. Kapag ang substance ay binubuo lang ng isang klase o uri ng atom, ang tawag dito ay isang element. Halimbawa ng mga elements ay oxygen, gold, carbon, silver, at marami pang iba. In fact, 118 silang lahat at makikita mo sila sa periodic table na laging pinapabili sa'yo ng teacher mo. Ang mga chemical compounds naman ay grupo ng mga atoms na nagdikit-dikit sa pamamagitan ng chemical, ionic, at iba pang uri ng bonds. Common na halimbawa ng compound ay purong tubig. Dahil ang tubig ay nabubuo pag nagdikit ang dalawang atom ng hydrogen at isang atom ng oxygen. Ang mga substances ay hindi na basta-basta nahati pa nang hindi napuputol ang bond o puwersa na nagdidikit sa mga atoms ng substance. Halimbawa, hindi mo basta-basta makukuha ang basic component ng water molecule na hydrogen at oxygen dahil magkakadikit sila. Kailangan mo muna gumamit ng puwersa na mas mataas sa force ng bond para mapaghiwalay mo sila. Gayun din at lalo na sa kaso ng mga elements. Ang components ng isang atom ng element ay mga subatomic particles na tinatawag nating protons, electrons, at neutrons. Ang puwersa na nagdidikit-dikit sa mga subatomic particles na ito ay tinatawag nating nuclear force. At kailangan mo ng puwersa na mas mataas pa sa nuclear force para ma-split mo ang isang atom ng element. Ang mga substances ay maaaring nasa iba't ibang phase tulad ng solid, gas, liquid o plasma. Maaaring magbago ng phase ang isang substance dahil sa pagbabago sa temperature o pressure sa paligid. Pag-uusapan natin ng mas malalim ang elements at compounds sa mga susunod pang episode. Ang mixture naman sa kabilang banda ay dalawa o higit pang uri ng atom o molecule na pinaghalo pero hindi pinagdikit-dikit ng isang bond. At dahil walang kahit na anong uri ng bond na nag-a-attract sa pagitan ng mga atom o molecule ng isang mixture, ay mas madali silang paghiwa-hiwalayin para makuha ang mga base components nila. Ilan sa mga paraan na ginagamit para paghiwalayin ang mga components ng isang mixture ay distillation, evaporation, chromatography, o kaya ay simpleng pagsasala o filtration. May dalawang types ng mixture. Ang una ay ang heterogeneous mixture. Ito ay dalawa o higit pang substance o mixture na pinagsama pero distinguishable o madali pa rin makilala yung mga components nito sa isa't isa. Halimbawa, pag pinaghalo mo ang buhangin sa tubig, magsasama sila physically pero hindi chemically. Kaya makikita mo pa rin yung mga buhangin sa tubig at mapaghihiwalay mo sila sa pamamagitan lang ng simpleng pagsasala. Isa pang halimbawa ng heterogeneous mixture ay kapag pinaghalo mo ang tubig at langis. Hindi mo sila totally mapagsasama physically at chemically at madali lang silang paghiwalayin sa isa't isa. Ang isa pang uri ng mixture ay ang homogeneous mixture o mas kilala sa tawag na solution. Kung gusto mong pakinggan ang buong discussion sa solution, ay pindutin ang link na ito para mapanood ang nakaraang episode ng Chokat Lapis tungkol dito. Ngayon ay may tanong ako sa inyo. Kapag ba kumuha ka ng tubig sa gripo, ito ba ay isang pure substance o isang mixture? Mas malamang na isa itong mixture kasi malaki ang chance na hindi naman purong tubig ito at baka may mga halong ibang element o compound tulad ng iron, calcium o sodium chloride. Pag ang tubig ay dumaan sa process na tinatawag nating distillation, ay makakasiguro na tayo na isa itong pure na tubig. Dahil inihiwalay sa process ng distillation ang lahat ng uri ng compound at element. Kaya purong mga bonded molecules na lang ng hydrogen at oxygen ang nandito. Siyempre, iba rin ang mineral water sa distilled water. Sa tawag pa lang, ang mineral water ay may mga halong ibang minerals, kaya isa itong mixture. Bumalik tayo sa unang tanong natin kanina. Ang tubig dagat ba ay isang substance o isang mixture? Obvious na ang sagot ngayon dito, di ba? Dahil ang tubig dagat ay binubuo ng dalawang compounds na tubig at asin, ay isa itong mixture. In summary, ang matter ay mahahati natin sa dalawang kategory, substances at mixture. Ang dalawang uri ng substance ay elements at compounds. Ang mga components ng elements at compounds ay bonded sa isa't isa, kaya mahirap na sila i-breakdown pa into their basic components. Ang mixture ay mga bagay na pinagsama physically pero walang kahit na anong bond sa isa't isa, at dahil dito ay madali silang mapaghiwalay into their basic components. Ang dalawang uri ng mixture ay heterogeneous at homogeneous mixtures. At ilan sa mga paraan na ginagamit para mapaghiwalay sa basic components nito ang mga mixture ay distillation, evaporation, filtration, at chromatography.
Okay, so I think malinaw sa inyo ang ating discussion about substance and mixture. So matter can be classified into pure substances and mixtures. When two or more kinds of matter are put together, it is called mixture. Mixtures can be made with solid, liquid, or gases. Any combination will result in a mixture. A pure substance consists of one phase with definite composition which appears uniform in appearance and composition regardless of its size. So, I hope na malinaw sa inyo at alam nyo ang difference. Kaya nyong i-differentiate ang pure substance and mixture. So, kung ito ay malinaw na sa inyo, I hope na nasagutan ninyo na ang inyong mga learning task for our week 3. So, now, we are going to proceed with our week 4, saturated and unsaturated. It will discuss the properties of both saturated and unsaturated solutions in this lesson. So, in this lesson, you will determine that solution can either be saturated or unsaturated. Are you familiar with these science terms describing the properties of solution? So, what are these properties that make solutions saturated and unsaturated? So, specifically, at the end of this lesson, you will learn to investigate properties of unsaturated and saturated solution. These are the cases where contaminants are present in some substances. The process of recrystallization can be used to remove these impurities. The crystals are dissolved in a hot solvent, forming a solution. When the solvent is cooled, the compound is no longer as soluble and will precipitate out of solution, leaving other materials still dissolved. So, for this lesson, let's have another video.
Nagising ka isang umaga. Nagpakulo ka ng mainit na tubig, inilagay mo sa tasa, at tinimplahan mo ng kape at asukal. Sa chemistry, ang tawag sa iniinom mo ngayon ay isang solution. Ano nga ba ang solution? Ang solution ay ang pinaghalong dalawa o higit pang bagay o substance na bumuo ng isang homogeneous mixture. Ang ibig sabihin ng homogeneous ay pantay-pantay ang proportion ng isang bagay kahit saang bahagi ka kumuha ng sample. Ang iniinom mong kape ay pareho ang lasa at itsura at chemical composition kahit sa ibabaw o sa ilalim ka ng tasa kumuha. Maliban na lang kung saturated na siya, dahil naparami ang lagay mo ng asukal na yung iba ay hindi na natunaw kaya parang mas matamis yung nasa ilalim ng tasa. Pag-uusapan natin ano ba ang ibig sabihin ng isang saturated solution mamaya. Ang isang solution ay may dalawang main components. Isa dito ay ang tinatawag nating solute o ang bagay na tinutunaw o natutunaw. Sa example natin kanina, ang kape at asukal. Ang tawag sa kakayahan ng isang substance na matunaw pag hinalo sa isa pang substance ay solubility. Ang isa pang bahagi ng solution ay ang tinatawag nating solvent o ang pinagtutunawan. Sa example ulit natin kanina, ang mainit na tubig. Maraming bagay ang pwedeng maging solvent, hindi lang tubig. Pero dahil napakaraming bagay ang natutunaw sa tubig, kaya tinatawag din siyang universal solvent. Ang tawag sa process ng paghalo ng solvent sa solute ay solvation. Ano ang mga properties o characteristic ng solution? Ang isang solution ay homogeneous o binubuo lang ng isang phase. Pangalawa, ang mga particle ng solute ay hindi na nakikita ng naked eye pag natunaw na. Pangatlo, hindi ikinakalat o nag-i-scatter ang liwanag pag tumama sa particles ng solution. May mga ibang uri kasi ng mixture na ang iba ay tinatawag nating colloids at suspensions na nag-i-scatter ng liwanag. Ang tawag sa ganitong pangyayari ay Tyndall effect, kung ang particle ay nagkukos ng pag-scatter ng light. Isa pang property ng solution ay hindi na nahihiwalay ang solute sa solvent sa pamamagitan ng pagsasala dahil nga napakaliit na ng kanilang mga particles. Halimbawa, meron kang isang basong tubig. Nilagyan mo ng isang kutsaritang asin. Matutunaw ba lahat ng asin? Malamang oo. Kung dinagdagan mo pa ng isa pang kutsarita, siguro matutunaw pa rin. Pero, pag dinagdagan mo ito ng dinagdagan, darating din sa punto na hindi na kayang tunawin ng tubig yung idinadagdag mong asin. Pag dumating ka na sa puntong ito, nakagawa ka na ng isang saturated solution. Ang ibig sabihin ng saturated solution ay masyado ng marami ang solute mo na hindi ka na pwede magtunaw pa ng karagdagang solute sa solvent. Pag nagdagdag ka pa, mananatili na sa solid state yung dinagdag mong solute. Ang tawag sa mga natirang solute na hindi na kayang tunawin ng solvent ay precipitate. May mga factors na nakakaapekto sa solubility o kakayahang matunaw ng isang solute. May mga bagay na nakakaapekto kung gaano kabagal o kabilis ito matunaw. Tanong, nakakaapekto ba sa tingin nyo sa bilis ng pagkatunaw ang bilis ng paghahalo o stirring? Siyempre oo. Dahil mas mabilis ang paghalo, mas mabilis magkakontak ang particle ng solvent sa particle ng solute, kaya mas mabilis silang magsama. Isa pang tanong, ano ang mas mabilis matunaw? Malalaki o maliliit na tipak ng asin? Ang sagot dito ay mas mabilis matunaw ang maliliit na tipak ng asin. Kasi mas mabilis balutan ng water particles ang maliit na surface area ng maliit na tipak ng asin. Tanong pa ulit, saan mas mabilis matunaw ang asukal? Sa mainit o sa malamig na tubig? Ang sagot dito ay sa mainit na tubig. Dahil mas mabilis kumilos ang mga particle ng tubig o kahit na anong particles in general kapag mas mainit ito. Kaya mas mabilis nitong tamaan paulit-ulit yung mga particle ng asukal. Pumunta naman tayo sa kaunting computation. Simple lang naman ang mga tanong sa solution. Kadalasan, ratio lang ng solute sa solution o concentration levels ng solution. Halimbawa, ano ba ang mas concentrated? 30 grams ng kape na hinalo sa 100 ml ng tubig o 10 grams ng kape na hinalo sa 20 ml na tubig? Maaaring may nag-iisip na mas concentrated yung may 30 grams na kape kasi mas maraming kape ang hinalo. Pero, kailangan mo ring isipin sa gaano karaming solvent mo siya inihalo. Para kunin ang concentration, i-divide mo lang ang solute sa solvent tapos i-multiply mo ang sagot sa 100%. Kaya, sa unang solution, 30 grams divided by 100 ml ay 0.3. Tapos, i-multiply mo ang 0.3 sa 100%. Kaya ang sagot ay 30% concentration ang unang solution. Sa pangalawang solution naman, 10 grams divided by 20 ml, ang sagot ay 0.5. Tapos i-multiply mo sa 100%, ito ay magiging 50%. Kaya, ano ang mas concentrated? Yung 30% solution o yung 50% solution? Siyempre, mas concentrated yung 50% solution. In summary, Ang solution ay isang uri ng homogeneous mixture. Ang dalawang components ng solution ay ang solute o ang bagay na tinutunaw at ang solvent o ang substance na pinagtutunawan. Ang pinakamadalas na ginagamit na solvent ay tubig, kaya tinatawag din itong universal solvent. Ang tawag sa kakayahan ng isang bagay na matunaw kapag hinalo sa isa pang bagay ay solubility. At ang process ng pagsasama ng solute at solvent ay tinatawag namang solvation. Ang tawag sa solution na hindi na kayang magtunaw ng karagdagang solute ay isang saturated solution. At ang ilan sa mga factors na nakakaapekto sa solubility ng isang bagay maliban sa natural property nito ay ang size ng solute, mas maliit ay mas mabilis matunaw, at ang temperature, mas mainit, mas mabilis ang process ng solvation. Lastly, para i-compute ang concentration level ng isang solution, ay i-divide mo lang ang dami ng solute sa dami ng solvent at i-multiply ang sagot sa 100%. At dyan nagtatapos ang lesson natin.
So at this time, we are going to proceed to our week 5 and concentration of solution lesson. So ito ay napahapyawan na kanina ang discussion about how are we going to get the concentration of solution. So medyo na-discuss na ng konti. But sa week 5, much more on ang mga problem solving here. So sa week 5, in this lesson, you will be applying your skills in preparing different concentration of solutions. In preparing this solution, you will express concentration of solution quantitatively by preparing different concentration of mixtures according to uses and availability. Many of the materials used in science are in the form of solution which can be available at home. For many purposes, the exact value of concentration is not critical. In other cases, the concentration of the solution and its method of preparation must be as accurate as possible. Quality and fresh chemicals and solvents are used. The meticulous procedures are followed. So here in our week 5, we're going to perform some of the activities. Thus, it is very important that when solutions are prepared, an extra care should be done and that the resources or materials should not be wasted. The available resources or poor method in the preparation of solution can greatly affect the result of the mixtures being prepared. For example, in pharmaceutical laboratories, the exact amount and concentration of each solution must be carefully done so as not to harm the health of the people or customers. Accurate solution can be prepared in laboratories because of the availability of materials. Since there is no access in the laboratory today, you will be preparing solute which are available at home. So ito yung ating nasa module week 5, page 32. But before that, let us proceed to the last video that we have for today. How to compute the concentration of solution.
So let's discuss concentration and solutions. Concentration of solutions describe a relative measurement of the amount of the solute that has been dissolved in each amount of solvent or solution. So there are two types. When there is a large amount of dissolved solute for a certain volume of solvent, it is called concentrated. And the other one is what we call dilute solution that has has a small or dissolved solute in comparison to the amount of. I have here an example of a concentrated and a dilute solution. As you can see in the picture, on the left side, notice how the dark solutions appear. So the blue one circles solid particle and the pink one is the solvent particle. In concentrated solution, more solid particle, while in the dilute solution, more solvent particle. So the color will be lighter. So the difference between dilute and concentrated. So in concentration, in dilute it is less concentrated. In concentrated, more concentrated siya. And in the amount of solute, so in dilute, less. In concentrated, more solute. In the color appearance, in dilute solution, it has a dark, and in concentrated, it has a dark color. This topic is about percent by mass and percent by volume in concentration of solution. There are several ways in expressing concentration by percent by mass, percent by volume. In percent by mass, it is in a solute in a solution in a solid, which is gram absolute per 100 grams. In percent by volume is often used in preparing solution in liquid. So this will multiply by 100. So I have here an example in getting a problem. A solution was prepared by mixing 25 grams of salt with 50 grams of water. So we will calculate the mass of solution. So step 1, identify the given. We have mass of solute, mass of solvent, and write the formula in. Step 3 is to substitute a given, then compute. So first write the formula. Write the mass of solute. Then write the mass of solution. Getting the mass of solution, solute plus the solvent in the problem. And after that, you will get or copy first the mass of solute in the next column. Next step is the sum of solute and the solvent. For that, times 100. Next, you have to divide the mass of solute and the mass of solution, then times 200, and you will get your answer. And always percent per volume, the same lang sa percent by mass. You will first identify the given, get the volume of solute, get the volume of solvent, then we will get the percent by volume. Write the formula, volume of solute divided volume of solution times 100. So here an example. And the last step is to get or substitute or get a given then. So write first the formula of percent by volume. Get the volume of solute. And get the volume of solution, solute, plus the solvent, and then times 2, 100. So next, just write first the volume of solute and the sum of the mass of solution. Next, you divide mass of solid to mass of solution. And that will be your answer for getting the percent by volume. Well, that's it. I hope you know how to.
Okay, so dahil mabilis masyado ang explanation ni ma'am, so sabi doon, the steps in calculating the concentration of solution is in getting the percentage of mass and also the percentage of volume. First, you have to identify the given. Next, you have to write the formula. And the last one is substitute the given, then compute. So what is the formula here is in getting the percentage by mass, you're going to divide the mass of the solute over the mass to the mass of the solution. Then multiply by 100. So the percentage by volume, you're going to multiply the volume of solute, i-divide sa volume of solution, multiply by 100. Okay? So, to sum up the week 5, kasi medyo mabilis ang video ni ma'am. Kahit ako hindi ko masyado maintindihan yung kanyang some of the words that has been mentioned in the video. So, concentration is the quantity of solute that is dissolved in a certain quantity of the solvent. It can be described, so concentration daw can be described as qualitatively or quantitatively. Okay, so sa qualitative, we're going using words such as dilute or concentrated. And doon naman sa ating quantitative, we're going to use the numbers. This is especially important when safety is an issue. So, numerical. Okay, so let's answer this. They're going to answer if it is quantitative or qualitative. It depends on the given. Or the given problem. Okay, let's try this. Food coloring made the water blue. Is it quantitative or qualitative? Correct. It is qualitative. But how about if the given is adding 3 ml of food coloring turned 250 ml of water blue? So, of course, that is quantitative kasi may mga numbers na nabanggit doon. Next. The water became warmer. Is it quantitative or qualitative? Correct. That is qualitative. But how about if the given is the water's temperature increased by 5 degrees Celsius? Of course, that is quantitative. Next, number 3. We needed just over a dozen floor tiles for our model room. Is it quantitative or qualitative? Correct, qualitative. But how about if we needed 14 floor tiles for our model room? Okay, since meron siyang numerical numbers na nabanggit, it is quantitative. Next, the liquid boiled in 5 minutes. Correct, quantitative. But how about the liquid took only a few minutes to boil? Correct, qualitative. Next, the mass of this solid is 5 grams more than that one. Correct, quantitative. But how about this solid is heavier than that one? Okay, qualitative. Okay, so how are we going to differentiate dilute from concentrated? When we say dilute, there is a small mass of dissolved solute for a certain quantity of solvent. But while concentrated, there is a large mass of dissolved solute for a certain quantity of solvent. So sa dilute, small mass of dissolved solute, while on concentrated, large mass of dissolved solute. Yun ang ating mga keywords to be remembered. So here is the example of dilute solution, and here is the example of concentrated solution. So kung mapapansin nyo, there is a difference sa color. At kung makikita nyo, mas thick ang particles, mas thick ang concentrated kaysa dilute. Okay, so let us proceed with our learning task number 1. You're going to read the handout above about preparations of, you need to read the handout about preparations of solutions. And then answer the guide question. So this is the handout entitled Solution Preparation. So this can be found on your module for our week 5. And then matatagpuan siya. Okay, so wait. I'll be giving you the page para hindi kayo malito. So, for our week 5, babasahin ang page, learning task 1, page 33, solution preparation. Then, pag nabasa nyo, you're going to answer the guide questions. So, we have 5 guide questions here. So, number 1, what is a solution? Number 2, what are the materials mentioned in the handout in preparing a solution using the first method? Number 3, are these materials available at home? 4, why is that manufacturing companies have this special kind of instrument in preparing solutions? Number 5, can you still prepare solution using available materials at home? And why? So for our learning task number 2, knowing the limitation of standard instruments in preparing solution, think of the available materials found at home that can be used in measuring solute and solvent when making solution listed below. So we have 5 items here. And then learning task number 3, you're going to choose materials found at home with known volume or measurement in making solution. Use the guide below. So here we have guide here for 6 items. So for 500 ml, it is equivalent to 2 glasses. The 50 ml is equals to 1 empty glass bottle. 4 gram is equals to 1 teaspoon. 14 gram is equals to 1 tablespoon. 180 ml is equals to 1 rice cooker cup. And number 6, 150 gram is equals to 1 cup. So this will serve as your guide to guide to choose materials that can be found at home with its equivalent value on volume. So you're going to answer the questions here. What materials will you use to measure the different amounts in preparing solution using the materials in the guide above? So we have also 5 items here. And then for our learning task number 4, using the available materials at home, make the following solution. Be careful in handling materials and use the same problem as a guide to help you solve the percentage composition of your prepared solution. Okay, so these are our solutions to make. Number 1, 450 gram flour and 1 liter of water. Number 2, 500 ml alcohol and 1 liter of water. Number 3, 300 gram rice grains and 540 ml of water. Number 4, 450 gram sugar and 360 ml coconut milk. Number 5, 50 ml liquid detergent and 250 ml of water. So these ends our discussion of our week 3, 4, and 5. I hope that it helped a lot in answering our module for the learning task for week 3, 4, and 5. So thank you for watching. God bless everyone. Stay safe and keep safe. God bless.